Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and this is a beautiful day for mathematics. Every day is a beautiful day for mathematics. Today we are specifically going to have a look at the Theorem of Pythagoras, but advanced problems. So in other words, when the questions that are asked are not always straightforward. For this, we are going to look at what we call composite triangles. Now, I will help you with that after the first one. So let's start by looking at the first question. There's the first question. I want you to hit the pause button, try it yourself. They're asking you to calculate the length of BC and secondly the length of BD. So hit the pause button, go for it, try it yourself. When we look at this kind of shape, man, some of these shapes the teachers can come up with can be like super complicated. So what I love to do, and I teach this even to my matrics, is when I've got a composite triangle, in other words, a triangle or a shape that has more than two triangles in it, I love to break them apart. So first of all, the blue colored triangle ABC. I love to then write the second one, triangle BCD, just break them apart and write down all the information we've got. Now I need to choose a triangle to work with. I always look for the one that has the most information. In this case, the one with the most information is actually triangle ABC. If I look at triangle ABC, I can apply the theorem of Pythagoras because I've got a 90 degree in there. I can actually also put a 90 degrees in triangle BCD. So when I look at the theorem of Pythagoras, again, let's just analyze why do I pick triangle ABC? Because I've got two sides. I've got the length of two sides. While I don't have that in triangle BCD, there I've got only the length of one side. So let's go and substitute our values in. And now I'm going to solve BC. So 100 is equal to 64 plus BC squared. Take it over. I'm left with BC squared being 36. Taking the square root on both sides. So the length of BC is 6. Now, please do not at this moment of time just go, whoa, I'm done, next question. No, write it in on the sketch and in all the triangles where you see a BC. So there's a 6 there in the big triangle, but also in the two small ones. Now I can move to triangle BCD. In triangle BCD, again, I can use a theorem of Pythagoras because there's a 90 degrees. So I'm going to say, well, it's 6 squared plus 9 squared is BD squared because that's now my hypotenuse. And this I'm going to calculate. BD squared is 117 because 6 squared is 36 and 9 squared is 81. So BD is the square root of 117, which is approximately 10,82 units long. Ta-da! There, I've done it. Now I want you to go and have a look at this next question. Remember our basic steps. Break the triangles apart. So in this one, I'm asking you to calculate the length of AB and CD. So I want you to break it apart for yourself and try it before you look at what I do. So how do I break it apart? That's a very good question. Well, I broke it apart with triangle ABC and triangle ABD. Okay? Now, why did I not use triangle? That blue one there, triangle ACD. Why did I not use that one? Well, simply because there's no 90 degree in it, so I can't use the theorem of Pythagoras. So if you look closely at the triangle ABD that I have at the bottom, you will see I put in that 5 for the length of BC, just so that I don't forget about it if I need to move over to that. So let's have a look at the first question. The first question is calculate the length of AB. So if I want to calculate the length of AB, well, there's a 90 degrees, so I can simply go towards Pythagoras. If I substitute in, I can go AB squared. Now I'm solving it, and I've got a length of AB as 12 units. If this went a bit too fast for you, try it yourself and make sure that you are able to get it. Could you have used Pythagorean triplets? Yes! If you don't know what it is, please watch the previous video. The previous video explains it wonderfully. So now, put in that 12 in all the different triangles. Oops, I forgot to put it in the big one. It's not a biggie, but it is important. So now I'm going to look at that bottom one to look at CD. So what I'm going to do is kind of come up with a plan. How do I get the length of CD? Well, I'm going to say, but CD plus BC is equal to BD. Why do I do that? Because I already have the length of BC, and I can calculate the length of BD using Pythagoras. So in other words, I'm going to calculate BD, get the length of BC, and then solve CD. So let's try that. BD squared plus AB squared must give me AD squared. So substituting in, I have BD squared is equal to 12 squared plus 20 squared. Solving 400 minus 144. So BD is equal to 16. If that's a bit too fast, remember, I'm taking the square root on both sides. And then I get to BD as being 16. So in other words, that length of BD is 16. So where do I go from here? Well, CD plus 5 must give me 16, and CD is 11. Whoa, so where did you get, where did you get this from? Remember what I wrote down there? Is I substituted those lengths for BC as being 5 and BD as being 16, and therefore CD is 11. And I hope that that makes sense, that if that is 5, if BC is 5, and the whole of BD is 16, then that has to be 11. I encourage you, go and try the sum again, just so you make 100% sure you get this. Rewatch the video, but try it yourself. And have a beautiful rest of your day, ladies and gents. This is Mr. VG signing out. Enjoy it, keep safe, and I hope you are going to have a magical mathematical rest of your day. Keep well. Cheers.